Hello. Hello. Am I audible? Yes. Okay. So we'd like to begin this session. So, good evening, everyone. As we gather here today for the complete introduction into SolidWorks webinar, I'm honored to welcome each one of you to this online event where we embark together on a journey of learning throughout this session. This webinar will help you understand SolidWorks, providing insights into CAD modeling and design, equipping you with skills to excel in your projects. I'm delighted to welcome our esteemed speaker for today, Charleston Oyoo, a recent graduate in mechanical engineering from Kenya. Charleston is not just a passionate learner, but also an accomplished professional, holding certificates as a certified SolidWorks associate and certified SolidWorks professional. Additionally, he's a proud SolidWorks champion, a testament to his expertise in his field. His vast knowledge and practical experience will undoubtedly make this session enriching for everyone, whether you are a beginner or an intermediate level in SolidWorks. I also extend a warm welcome to all the students and participants who have joined us today from various places. Your enthusiasm and eagerness to learn makes this event even more special. Thank you all for being here, and let's make the most of this opportunity to learn, engage, and inspire each other. I would now like to invite Charleston to take over and guide us through this incredible session.
To appear here, and then I click equal. I want to make them equal. Yeah, so you can see it's fully defined. I've just, so it typically means that this line and this line is 90 degrees. Yeah, and after a sketch is fully defined, it means somebody can understand it. In case I try defining it again like 90, you're going to see I'm getting an error, like overdefined error, meaning like this thing is already defined. I can't continue defining it. For example, but once you're uh, diameter 100, and then I want to make it tangent to this square. So click on this side where you want it, and then press on Control, and then click on the circle, and then you choose the tangent relation. You can see it from my screen or from my end. That way, you can see it's tangent now to the square. Just it's moving along that lane. Yeah. And let's assume there was also another line extending from here. You can see the line is horizontal, right? And then you wanted this arc again to be tangent to this line. Just click on that and then tangent. So you can see that's how you can work with relations. There's the horizontal relation, the vertical, the tangent, the equal relation. So for example, this one is diameter 100, and then I draw another circle over here of, I want it to be the same diameter of 100. So instead of, I can use the smart dimension to give out the dimension like 100. Let's say it's this way. Or if I don't want it that way, I can just go back and then I'll click on this circle, control, control on your keyboard, and then click on this other circle and then make it equal. Yeah, that's the equal relation in SolidWorks. So let's say I also want to make it this way, like tangent. Click on the circle, control, click on this line. So make it tangent, yeah, that way. So you can see those are the common relations in SolidWorks that you can truly use. Unless I want to constrain it by making it also tangent to this one, I'll just click on that line, control, tangent. Yeah, so it's fixed in that space. So the sketch is like you can just see how it looks like. Yeah, so typically those are the basics of what I wanted to illustrate in 2D sketching. And then another important thing in 2D sketching, there's also another tools like the ellipse. You can just draw like this, and then ellipse is that way. You give it out the vertical distance. Let's say it's 145 as it appears there. And then you also give out this horizontal. center distance. That's like 300. Some of the sort. So there are many tools, 2D tools you can use over here. There's the ellipse, and then the spline. I also illustrated the polygon, also the slot. The slot is just this one, some of the sort. So for the slot, you give out um the radius. So let's say the radius is 70. And then you also give out the center distance just to illustrate what's needed. Let's say the center distance is 250. So it's that way. You can see how it looks like. So typically, these are the most common tools you'll be using in almost all your things, all the things you'll be working on. So just to delete these things, let me just delete this. No, 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 let me not delete. Let me just delete these two, the ellipse and the sketch. I want to illustrate something about trim entities. Yeah. So in SolidWorks, like we have trim entities. It's used to remove unwanted part, right? So let's say there was another circle this way, and it extends up to this point. And then there's also another circle. I've drawn it from the center point up to this point. You can see basically this circle, like it has some of the things you don't require. So you, for example, you want to remove this part, this part, this part, this part. You're going to use the trim entities trim tool to do that. So just click on trim. There are various types of trim. There's the trim to closest, and then there's the power trim. You can't use all of them. My favorite one is the power trim because I find it to be very fast. Yeah, but for beginners level, you can use trim to closest. For example, just click here and then it removes. Just click here, 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 and then it removes. You can see now the part is so clear. But me, I love using power trim because I find it to be very fast and efficient. So for beginner, you can use trim to closest or power trim. Power trim is nice because you just take it this way and then you just drag it like this, and then it just cuts the things you don't want. You see, but it's just the same thing. You're just going to remove the part. So you can either use trim to closest or power trim. All of them do the same job. So that's trim entities. Yeah. And then another tool. Okay, if you want to zoom, you can do this way. You can just scroll, use your mouse wheel to in and out. Yeah, it's just going to trim it. You're going to zoom it, zoom your drawing. To illustrate the offset tool and the mirror tool. So the offset tool and the mirror tool, and then from there we can proceed a little bit. So let me just delete this. Yes to all. So let's say I do a circle layer of diameter. Let me assume it's diameter. It's 175. So let's assume it's 176, diameter 176. Yeah. So in case, another special thing, in case you gave it a diameter of 176, but you wanted it to be like 200 in diameter, just double click on the on the units I've given out, on the values. I mean, for example, this one is 176, and you wanted it to be 180 or 200. Let's say 200. Just double click on it and do the changes here. 200. It will adjust automatically. Let's say you wanted it to be 250. Just double click on it and then 250. So that's how you can typically do your changes. So there's another special tool known as the offset tool. Offset is used to give like some margin around, yeah, some thickness or margins, just something of the sort, yeah. So just click on the tool offset and then click on the sketch. So this one is, it means it has offsetted the circle a diameter of a decent meters. Yeah. So for example, you wanted it to offset like 30. So it means the distance between this inner circle and outer circle is 30 millimeters, right? And then there are other, go to your mirrors tab here, and then it will ask you entities to mirror. Entities to mirror is what you want to mirror. I want to mirror this circle about this line. You can see the preview. Yeah. So typically that's how you do it. That's how you use, you have to place the point of mirroring. Yeah. So let's say I placed a center line over here, and I want to mirror this circle about this center line. Just go to the mirror, and then entities to mirror is this circle, mirror about this line. You can see it has been mirrored. Yeah, it has been mirrored about this line. Let's say I want to mirror these two circles about this line. So go to mirror entities. Entities to mirror these two circles, just select those two circles and then mirror about this line going to be mirrored. So typically that's the concept of mirroring. Yeah, that's the concept of mirroring. Yeah, I hope you guys get it. So let's say I don't want this thing, you can utilize things like the trim and just remove the unwanted. I don't want them. So I'll do the last part. The last part is the sketching. I mean the linear sketch pattern, the patterns. So there are various types of patterns in 2D sketching. In 2D sketching, there are only two, like the linear and the circular. But overall, when you check the 3D sketching, you'll find there are various types of patterns you can make. But since you are still in 2D sketching, we can use okay, let's do the linear sketch pattern. Linear sketch pattern typically means like pattern in a straight line, a pattern that follows a line, a straight line, that is. So let's say you want to mirror, like you want to pattern like these two things along this line, follow this line, right? So you just click on linear sketch pattern, and then the direction, I want it to follow this line. So just clear the one you found and then click on this line, and then you click on, just drag here, then entities to pattern, you just click, for example, I want to click on this, and then how many instances do you want? I want like, let's say 5 instances, and then here you give the distance between each instance. So um, let's say the distance between them is 400. Yeah, so you can see like I the I mean the entities to pattern is this circle. I want to pattern it. I want 5 instances of it, and then the distance between each of them will be 400 millimeters. The center, I mean the center distance difference. Yeah, the difference in the center distance will be 400, and then I want 5 instances. It will give you 5 of them, right? And then you can see. And then you can also choose the day. I've not drawn the other one, but that's the concept of it. So let's say it's that way. You can see now you have created 5 instances of it instead of doing like each modeling each and every one of them. So I'll do the next one. Let's also want to create an instance of this, the pattern instance of this. So I go down, and then the entities to pattern will be this. And then actually the first thing you have to do is to select the direction you want. So I want is that line sketch. And then I want how many instances? Okay, the distance between them, let's make them 400. But I want only 3 instances. You can see 3 instances will be created. So typically, this is how you go about it. That's everything about 2D sketching. Some of the things you have to know for beginner level. Just know those ones. Smart dimensions is used to give distance. Then this one is the rectangle, the line, the slot. That's where everything else is built from. So you have to start from the 2D sketching. So from there, I hope you guys have understood up to 2D sketching, like whatever I've discussed up to wherever I've reached right now, right? Yes? Maybe one person can respond by telling me it's well. One person can respond kindly. Okay, thanks so much. So I hope you have understood the up to 2D sketching. So typically that's all that happens in 2D sketching. So when you want to exit your sketch, there's this exit tool over here. Just click on it, and then it will exit the sketch. When you want to go back to the sketch, just click on it, and then the first thing is edit sketch, and then you're going to do it like that. So typically that's up to 2D sketching. So I want to transition to 3D sketching. Actually, this is where the fun part of it comes in. Yeah, I don't want to say that one. So I'll just open the window again. then I'll open part. I'll now go into 3D sketching. So I'll assume you've gotten the concept of 2D sketching, and then we'll proceed to 3D modeling or 3D designs. And now we'll be exiting from this window to this window. So 3D sketching. So one thing you have to understand is that 3D modeling, or 3D design is very reliant on 2D sketches or the 2D designs you're going to make. So the first thing you have to do is to make sure you have your 2D sketches handy. So let's say I want to draw a cylinder. A cylinder typically, its cross section is a circle, right? It's a circle. So click on the circle, and then it will ask you like which plane do you want to draw this cylinder from. I want the cylinder to come from down to go upwards. So I'm going to use the top plane. You can also do it. Okay, I'll use the top plane. I'll select this top plane. I'll click. As I said, begin your sketches from the origin. It's going to make your work easier. So do that and then click here. Let's say it's 100 millimeters in diameter and it's fully defined. So after you've drawn your sketch, this is a cross section, just like a 2D representation, but you want it to be a cylinder. So the difference between 2D and 3D sketches is 2D sketches is just in two dimensions, just as the name purports. But in 3D sketches, in 3D model, you have to include a volume to your 2D sketch. For example, this thing is just there, it doesn't have any volume. It's just like on a typical piece of paper, like it has no thickness or some other sort. Yeah. So you want to give it some thickness. That's where 3D comes in. Yeah, it's no longer a 2D sketch, but a 3D model. So go to features. So there are various tools here. We're going to explore all of them. We have the extruded boss base, which is used to give volume. So click on it, and then you can see it's going to this blind. You can, let's say you wanted it to be a height of 200. So just click there 200, and you can see it has been given a volume of 200. Yeah, you can see now this is a cylinder and it has been given a volume of 200 millimeters. Yeah, so this is an example of extruded boss. It's used to give volume. Let me illustrate another time, now using another different plane so that you get the concepts of the plane. So for example, I want to draw a cuboid. A cuboid is cross-sectional, is typically a rectangle. So I want to draw it this time from a front plane or a right plane. Let me do the right plane. So I'll click on that rectangle and then click on this right plane. And then it's going to bring me to that page. And then I'll just do that. And let's say I give it like 160 oh, let me just give it 200 millimeters as the length, and then the other side I'm going to give it 100 millimeters. So this is it. So if you've drawn it that way, it's fully defined. You simply go to features and then you go to extruded boss base to give it volume. Let's say I want to give it a volume of 250 millimeters. You can see it has given it a volume. If you want it to go the other direction, you simply switch it using this tool. You can toggle it. You can see toggling it. Yeah. So let's say I wanted to go that direction, 250 millimeters, then that's way. So this is a cuboid. So extruded boss base is used to give volume, volume to a 2D sketch. So as you saw, the 2D sketch we drew was this one. It was 200 by 100 millimeters, and then we gave it a volume of. So, for example, I want to teach you another tool, by the way. It's known as the measuring tool. It's using the evaluate tool. For example, you want to confirm, like you've drawn this, but you forgot somehow. Okay, you can go back to the sketch you drew, or you can use the evaluate tab here. There's a tool known as the measure tool. It's just an icon of a tape measure. So click on the measure tool and then you can just come and click like this length, and it will tell you the length is 200. This, the width is 200, the height 100, and then this length is 250. So typically that's how the measure tool, you can use it to do such things. Let me check the other one. You can use the measure tool. Just click on measure and then click on the circle. It's going to tell you the circle is diameter 100 millimeters. And then when you want to find the height of it, you can measure it like this height. You can see the center height is 200 millimeters. That's the distance we extruded. So that's the extruded boss base, and that's all it is used for. And another thing you can typically do is you can also, it's not a must you draw on these primary planes. You can model also on top of a surface or a face. Yeah. So let's say I want to model on this face. Let's say I want to add two circles on this face. Just go to sketch again, click on this circle. It's going to ask you which plane or edge or planar face do you want to sketch from, and then I click on this face. It's going to be orthogonal. Orthogonal is simply means normal. Yeah, it's going to be normal. So let's say I want to draw other two circles on it. I just draw some two circles on it. Yeah. And then let's say after I've drawn the two circles, I can decide to, but make sure you define your circles by the way. I'm just illustrating. So this one is, let's say I want it to go like 100 millimeters height. Yeah. So you can typically draw on any face you want. Let's say I want to draw on this face again. So you can typically, that ways you can first click on the sketch, or on my side I love clicking on the face first and then I sketch from the face, because I know I want to model something from this face. So just click on this face and then the sketch icon is here that way. So it's going to be normal or orthogonal. Then you draw your circle. Define it by giving it the dimension, and then you can extrude boss it. Extruded boss is used to give a volume. So that's it. I hope you can see how it looks like. So you can typically draw on any face. Let's say I want to draw on this face. Just click on the face where you want to add another dimension, another model or part. So click on it this way, and then the sketch icon is here. Click on it that way. And then you typically put your, let's say I want to do a rectangle this time round. Click your rectangle that way. And then you extrude boss it. I mean, giving it a volume. You can give it a volume by saying like it's 50 up to there, right? So you can see that's how it looks like. So that's boss. And then you will realize that your feature tree increases as you add more features. It The feature tree increases. Yeah. And you can you can roll back to wherever you started by clicking on this line and then just simply dragging it to where you want it. Let's say I want to go back to where I started. This is what I started from. Then you can just, for example, you want to illustrate to someone or to your client or to your student how you did this thing. You can just roll back and then just simply drag it as well up to there. You can just drag it up to there, and then uh, I drag it again up to there. So you can see like these are all back. It shows I've used 4 features so far, and the features are extrude boss. So in case you wanted to change the dimensions of this one, you just click on it this way. You can see it points back to the feature tree where it is. The feature tree is boss extrude. Yeah. So you can simply click on it, you will see the part, and then when you down click this arrow, you'll see the sketch. So the sketch is the 2D foundation where it came from. So you can click on this sketch and edit sketch. Let's say you want it to be a dia of 130 and 50. After you're done, you just click exit sketch and it will adjust automatically. Let's say you didn't want it that way. Let's say you wanted another dimension. Just click on this one. So just click on it that way, or just click on it this way and then down click. You're going to find the sketch. And then edit the sketch. And then let's say you wanted it to be 100 millimeters. That's 130. Just double click on the stuff, then make it 100. And then this one, let's say you wanted it to be 80, just double click on it and then go where the values are 80. you'll see it adjusts up to 80, and then you click exit the sketch. So you see that changes. So that's boss. Boss is used to give volume. So I hope you've understood up to there technically. And I want to explore other tools. The other tools I want to explore the revolve boss base. So I will click on new. So revolve boss base is typically used to work on things with okay, perfect revolutions, right? For example, when you see a bottle, it's a revolved thing. When you see a tire, it's a revolved thing. Yeah, and things like that. So let me illustrate the revolve boss base 3D command. So let's say you first go to the sketch where you want to sketch on. I'll go to the front sketch, the front plane, and then click on sketch. And then I'll draw. Let's say I want to draw something. Just draw something of the sort. Something of the sort like this. Then you can just give out your dimensions. So let's make this 90 millimeters, and then on this end I'm going to make it like, let's say 80, and let's assume it's something of the sort like this. Okay, don't mind. Yeah, so you just give out your dimensions the way you want. Let's say I wanted that 18.38, and then this height is 21.03. Let me just assume, like, I'm not guided by anything anyway. I'm just trying to illustrate these tools. So let's say this 16. Yeah, I go to, let's say I want to use an arc this time. But then for arcs, there are three types of arcs. There's the center point, there's the 3 point, and the tangent. The ones I use most of the times are 3 point and center. It depends with the function you want to use. So let's take like this 3 point arc. So I'll click on this point, then this point. Some of the sort, right? And then let's say I give it a diameter of 80, a radius of 80. This is how it looks like, right? So let's say I want to revolve this thing. Yeah. So for example, when you want to revolve a bottle, you take its cross-sectional area and then take like a quarter of it, so that it will revolve like 360 degrees. So I go to, after I've drawn my sketch, I go to features and then go to boss base, revolved boss base. So it will ask me for the axis of revolution. The axis of revolution is where you want it to revolve about. Let's say I want it to revolve around this axis or this edge or this line. Just click on that line. And then you'll see it has revolved 360 degrees to where I want it to be. So this is the final thing I'm going to get, right? Let me just delete it. I go back to revolve boss base, and then I want to revolve it about this line. So the line you revolve it about is very, very crucial. So you'll see whatever feature I come up with, right? It depends with the axis of revolution you want it to be. So this one, I go, not the sketch, I didn't want the sketch. So let's go back to revolve boss base, and then I choose another axis of revolution just to illustrate these things. So I click this line to be the axis of revolution. You see, it's giving me different features. You see, yeah. But let me go back to the original one, or let me just try to illustrate again using a bottle. Very rough bottle. It won't be perfect, but just an illustration of bottles. Yeah. So I go to my 2D sketch. Let's say I want it on the front plane. Click on the front plane and then sketch. Then I'll do the line. Like I just want a normal bottle, like those bottles. Nothing big. Don't mind me so much. I'm just illustrating these things. Just a small bottle. Nothing big. I don't have dimensions, so I'll just do to illustrate for you the essence of whatever I mean. Yeah. So just bear with me and just follow along. Just want to illustrate what revolve is. So let's just assume this is a container you have, a small container you want. Yeah, you use the revolve boss base. So go there and then just click on this line. Yeah, so it's going to give the revolve boss base. Going to, so whatever I've created is a revolve boss base. Yeah, it's just draw the cross section and then the line of revolution. It's going to give you something of the sort. So be very very I hope it's interesting as it goes. So that's the Volve boss base. So the next one I want to teach you is the extruded cut, and then I'll go to the swept, the lofted, and the rest. Yeah. So there's something known as the cut. Extruded cut is just the opposite of extruded boss. So boss adds volume while extruded cut removes volume. So that it's just like the opposite of each other. While boss adds volume to a sketch, the what do we call it? The extruded cut removes the volume. So let me just go back to the top plane as I did, and then I'll sketch on it like this. Let's say I want to create a cuboid once again. So I'll make this like 100 millimeters and then go back to this, make it like 230 millimeters. You see my sketch is fully defined and then I go to extrude boss base. And then let me give it a volume of 150. 150 is too big, but it's still surface whatever you want. So this is a typical volume, a 3D volume, or rather a 3D model with a volume from a sketch, right? So this, you can see this is a cuboid, but you want to create some two holes across it. So just click on this face and then sketch, yeah? And then go to circles. Let's say you want to drill a circle there. And then I'll be illustrating the tools I've discussed by this. So learn from it. So let's say circle of diameter 50 through the cuboid, right? So click on here. You have to fully define it. Remember that it's floating. It shouldn't be floating. You have to fully constrain it. So let's say the distance from the center point to the center of the circle is 69. And then the vertical distance from, let's say, this point to this point is 70. So you see, my circle is fully defined, it's fully constrained, it can't move at all. It can't move at all. So let's say I want to make the two of them. So let's make this line over here. These are 2D sketching, by the way. I'm doing a 2D sketch on a 3D surface. So I want to mirror this one to the other side. So I can just go to mirror entities. What do you want to mirror? Entities to mirror is this one, and then you mirror it about this center line you've created. Under the sort. So one thing you have to know is boss extruded boss base adds volume. Let's say I want it to go like 20. It adds volume. But for this case, we don't want extrude boss base. We want to use extrude cut, which is used to remove the volume. Yeah. So this is how the sketch was. Go back to features and then click on cut, extrude cut. And then you specify the depth of cut. You can specify like you want the depth of cut to be 30 millimeters deep. And you see, it will only be cut 30 millimeters deep. But when you want it to go like up to the other end, there's another option here known as through all, cut through all. So it will cut the material up to infinity. So it will go this way. So you can see the thing is it has some holes that have been drilled through it. So that's extruded cut, right? Let's say I want to cut a square between these points. I click on this face and then sketch. And then I click another square like this. I just create a square that way. That's a rectangle. And then you just give it the dimensions you want and then you cut. So cut, you can specify the depth of cut like 30 millimeters, or if it's not that way, you want it to cut through all, just go back to edit and then down click here through all. It's going to cut up to infinity. So you see. So this is basically the tools that are being used. So we have discussed the boss, the revolved boss, And then we also discussed the extrude cut. Yeah. So to illustrate, so the one remaining is the swept boss base, the lofted, and maybe the revolved, loft, and swept, and then we'll be through with that for 3D modeling. So for example, the fillets. I want to illustrate something known as the fillet before I continue with the rest, just to show you the essence of it. So in production, let's say you are producing a metal of this caliber or of this shape and features. You when you produce it, let's say using a CNC or anything, when it's produced, these edges can be very, very sharp. So it can't be used by a typical human being. Like it's not safe at all to be used. So that's where things like the fillets and the chamfers comes in. They're used to mitigate the sharp edges. So just to make something aesthetically appealing. So I click on the fillet and then it's just used to give it some like smoothness along the edges to avoid it being sharp. So for example, I want it to be, you specify the distance, I mean the radius of fillet. So this one. You can see when I click the edge, it gives it the same way to that one. You can also click it as a face, but I love using edges. It appears more appealing for this case. So for example, that one. So it will show you that this radius is fillet of radius 10. You can also increase the radius by checking this other side. Just increase it. You see, 20, 30, 40. It depends with how you want it. So let's say it's 10, that's 20, that's radius 40, radius 50. So let's say I wanted it to be radius 30. I'll just leave it at 30 and then I'll click on that. So that's the fillet tool we've just explored. It's used to make the edges smooth and not sharp. Yeah. So let me mitigate, let me hide that fillet. I don't want it. I want to illustrate chamfer on the other hand. So I'll just drag it a little bit up to there. I don't want it, I just want to illustrate. So when you down click on this arrow for fillet, you're going to find chamfer. So chamfer, you can use it this way. Just click it. You can see it's giving some taper of like the distance you want. For example, I can give out the distance here and the angle in which it's going to cut. So this angle is like 45 degree, like here to here is 45, 45, then it cuts that way. So you can see the difference between the other one was a fillet and then this was a chamfer. Yeah, so the edges are no longer sharp. So this is a chamfer and then for fillet is different. Fillet is different. Let me do it just here to illustrate again. Let me give it a fillet of 10. So this is a fillet and then this is a chamfer. Chamfer, fillet. So that's just the fundamental of it, of chamfers and the fillets. Yeah. So that's just a fundamental of it. So I have to go to, but before that, there are many features over here, like maybe mirror, just to illustrate to you the essence of mirroring and such, right? So let me illustrate a mirror in 3D. We already did the mirror in 2D sketches, right? So mirroring in 3D, we are going to mirror the part or the feature against, or rather using the plane. We don't use the the center lines anymore in 3D because it's a 3D feature. So let's say like this part, I click on this surface that way, and then let's say I click like I make some two cylinders on top here. Let me just give it a dimension of 40. You can see I was drawing on that plane, so don't get confused. Then I extrude it to a height of 30, let's say that way. So let's say you want to mirror this extrusion to the other part, right? That's where the mirror command in 3D comes in. So you don't go back to this one. This one is, in fact, it's even it's not even working. So for 3D, you use 3D mirroring. So you click on the mirror command, and then it will ask you for the face or the plane where you want to mirror this. So the plane at the middle is typically the right plane, I guess. You can see the right plane is at the middle, the right plane. And then the features to mirror, you can click on it this way or you click here. Then you just check it that way. So you see it's mirroring. It's a mirror feature of the sort. Yeah. And let me just assume, let me roll back. So this one was the mirroring. And whenever you're doing boss base, um, when you want something to stick or to be merged to the face where you're doing, make sure this merge result is checked. If you don't check it like this, then it's going to be two different bodies. You'll see here the bodies part shows that we have two different bodies. For example, the first body is this one, and then the second body is this one. But when you merge it, it means it becomes one body to the original body you had. So like you merge it this way. So it's different, like that is for merge. But when you do it as bodies, it means you're going to create two different entities on that body. So when you come to mirroring, you come to mirror. The face that's in the middle of this is the right plane. And then this time round, you're not going to use the features to mirror since it's not merged, but you go to bodies to mirror because we have two bodies here. Remember that we split the bodies. So just click on this body and then you click on checked. So you see like you have created bodies. So you'll see even the bodies increase. The first body is the fillet where we created. And then the second body is the one we did here. And then the third body is the body that we mirrored. So typically that's mirroring in 3D sketching. That's typically what you use. And I hope it's interesting that way. You can also mirror a cut. So let's say I click on this face and I make a small rectangular cut on this side. So I go to it that way. That's how it looks like, by the way. I go to extrude cut, and then let's say I only cut it to a distance of 10 millimeters. So you see, there's a cut here, but there's no cut on this other side. And you want to mirror this cut to go to the other side. So you click on mirror again, click on mirror and then the face to mirror it. Find the face, find the plane that is on the middle of the model where you want to mirror, like that one. You can see the right plane is on the mirror. And then you go to features because these are cuts anyway. And then you can just click this one, the cut on this side, or you can directly go to it like that. You can see a preview of it there in yellow. Then you click on checked. So you see the mirror is working. It's working really, really well. So guys, that's mirroring in 3D, where you can mirror the extruded boss base features or the extruded cut features, or even the things like fillets and chamfers, you can mirror them in 3D sketching using the mirror command, mirror 3D command, right? So I want to illustrate another tool, and that tool is, I hope you guys have gotten it up to there. I want to illustrate another tool that is let me roll back these ones. I wanted to go to these ones, but let me go to, instead of swept boss base, I was thinking if I can do these ones, like maybe the linear command and maybe the circular command, right? Let me think. So let me roll back. Or rather, no. Let me just delete that one. That way. So for linear command, we saw the other side. We saw on in 2D sketching what it entails. So this side now we use it in 3D sketching. So click on it like this one, linear command, linear pattern command, and then the direction. Let's say I want to create a pattern of this body over here, right? So I'll click on direction. Direction is a line where you want it to go. For example, I want it to go along this part like this up to the end. So I'll just click any straight path going along the path I want. For example, this line can be a path, this one can be one, this one can be another path, this one can be another path. It depends with your liking. So I'll just go with this one. And then since this one we left it as a body, we just go to bodies. And then like we give the instance. Let's say I want like 5 of them. And then the distance between them is not 5, let me do 4 of them. Then the distance between them is like 55. And then you check. Once it's satisfactory, you check it. So you see, I've created a pattern of those things over there, right? I hope you see it very well. So for patterns, you can also create for extrude cut features, right? So let me create some cuts on this surface. So click on this and then sketch. And then I create like some small circle here. Hmm. Okay, so you can see this circle is over there, and then I go to cut and then cut it. I'm illustrating the linear sketch pattern, by the way. So let's say it cuts up to a depth of 10. You can see how it looks like. So I want to create a pattern of this cut along this line. So I go to my linear sketch pattern, and then the direction, I choose this direction, and then features and faces. I can just click on this cut or come here and then click on the extrude cut. So I can give like I want like 8 instances, but the distance between them is let's say 20, and I want 10, 8, 9 instances. So you see, you can create patterns of it instead of redoing the sketches all over again. Yeah, so you use the sketch pattern to make your work easier. You can use the linear sketch pattern. As you have seen, I've made these things with the help of linear sketch. This also is the linear sketch. And then we have the circular sketch pattern. Let me try illustrate it. Mhm. Okay, let me go to this face, sketch, control 8. So let's say I want to draw another circle here. That way. It's too small, too small, but it makes sense. So let's say it's diameter 8. Then the distance between this circle, it should have brought me this way, but I'll just choose this vertical one. Let's say it's 110. Hello, 112. It's up to there. So let's say I boss it, extrude boss it to a height of, let's say like 5. I cancelled it. Let's give it extrusion of 5. Then I check it to means that I'm satisfied with it. So when you want to do it, when you want to do the circular sketch pattern is, for example, you want this extrusion to go round pattern, for example, through this thing. So the way you go about it is down click here, go to circular pattern, direction. You can see it's even giving you some revolutions, meaning you have to choose a circle direction. So for my case, you can either choose this face or this edge. It depends with you. So for example, I'll choose this edge, and then the features to pattern, I'll choose. Like for example, you want them to be like 10 around that thing, and then the features to pattern, just come and click on this that extrusion. Then you check it. So you see, like that's the circular sketch pattern. It's going to go around the circular edge you want it to go around. So that's it. And I hope you've gotten the concept of the patterns and the sketch. I mean the patterns and the fillets and the chamfers and the mirroring in 3D. So in mirroring again, let's say I want to, that's the middle plane. I want to mirror this, just illustrating mirroring again. Now you want to mirror these circles to the other side. You can see the note here on this other side, and you want to mirror it. You won't start redoing that thing again, but you go to your mirroring, and then you go to the plane, the center plane. Let me check it. It's the front plane technically. You can see the front plane there is at the middle, and then the features to mirror. You just click on the circular pattern along this side, like here, circular pattern goes this way. So you see, like the pattern is mirrored on the other side, and you see your feature tree is also growing. It shows the steps you have followed to come up with such a feature, like from the start to the end, to the cuts, to the mirroring, to the patterns. The feature tree increases. Yeah. So you have to take note of that as well. So that's just an illustration of how to use a mirror, how to use the pattern, the fillets, the chamfers. So I want to go to, and also revolve. I hope you have not forgotten the revolve boss base. I want to go to the swept boss base and then the lofted boss base, and then we will call it technically a RAW for 3D. So in the next 8 minutes, I want to finish up on the 2D, on the 3D tools, and then I'll let you do them, and then we'll go to the assembly part of it. So I want to illustrate swept boss base. So I'll open a new document, a new part document. So I'll go to parts. Mhm. Okay. So for part, and I want to illustrate the swept boss base. So the swept boss base typically revolve around something like a sketch pattern following a path, a given path. For example, take a case instance of your wire or a USB cable, or typically just take a path for a wire. A wire is an example of a boss base. Oh, kindly mute, kindly. So I'm going to illustrate the swept boss base. A swept boss base simply means like a sketch pattern following a given path. And with that, you're going to learn some new things like planes, doing it in planes. As I said earlier, that we have the three primary planes: the front, the top, and the right. So for the sketch pattern, for the swept boss base, I say we must have a sketch and a path which the sketch is going to follow. For case instance is a wire, like to take any instance of any wire like your USB cable wire, it's a circle cross section following a path. That path is the wire itself, the flexible path. Yeah, it's not a rigid path like a pipe or a shaft. Yeah, even shafts you can do in swept boss base, but it's rather you do it in, as revolved or as boss base. But for something like a cable, you use swept. So let me draw a path first. Let me use the front plane. I find it to be more suitable. So click on the front plane here and then sketch. So for a path, I want to use this spline. This is a tool known as the spline tool. It's just used to draw, like you want to draw some intricate shapes, you can use the spline tool. It's very helpful, by the way. So like you can draw something like this. You can see. So your wire usually looks like this. I know your wires looks like this. Let's assume this is your USB cable. Yeah. Then I exit. Okay, you can define it the way you want by giving it dimensions, but for my case, I won't give it dimension. So the first thing you have to create is a path. So I'll exit the path that way. So that's a path. And then this path, there is a cross section following this path from this start to the end. So you have to create that sketch profile that's going to follow the path which I've just created. So you're going to do this something known as the planes. These are the normal planes, but I want to create another plane. So for you to create another plane where you're going to draw the sketch pattern, you use reference geometry over here, this tab over here, to come up with another plane. So click on plane. It's going to open this window over here. Then click on this path, and then the tip where you want the path to begin or to be sketched on. So you see, this is a plane I've created, and I want to draw a path. I want to draw a sketch that's going to follow this path. Yeah, so you check it that way. So you can see that's where the plane is. So when you want to sketch on a plane as I did to the previous planes. You just click on the plane this way and then click on sketch. So it's sketching that way. So let's say I wanted a circle like your typical USB cable. So I'll take this circle and let's say I make it diameter. Your USB cable is typically like 2 millimeters thickness. So let me say 3 millimeters thickness. Some of the sorts more realistic. Then you exit. So one thing you're going to notice is that you have two sketches. There's the path and then there's the sketch plane. I mean the sketch itself and then we have the path. So when you want to hide this plane, just click on the plane and then the hide icon is here. Just click on it that way. So when you go to your swept boss base, you click on the swept boss base and then it's going you can see the sketch profile. It has two parameters. You have the sketch profile, then you have the path profile. So you click on the sketch profile like this, and then you click on the path profile like this, and you see it follows the path. The sketch follows the path to come up with something of the sort, right? You can all see now this is known as a swept boost base typically, but in SolidWorks, by the way, SolidWorks made it easier for you. You don't have to create the circles by the ones for circles. For circle, I mean the circle sketch. Just go to your swept boss base. You can just create the path and then click here on the circular profile and then click on the path, and then you specify the diameter of the circle. It was just used to make work easier. But now assume you don't use a circle, like you use a rectangle or something of the sort. You have to draw your own, you have to give it your own path by the way. So let me edit this one. So this is a circle. Let's say I didn't want a circle. I wanted it to go like a square, or let's use a polygon this time round. And this is a pentagon, and then let me make this horizontal that way. Then let's say it's one. So typically you want it to follow this path, right? So go to your swept boss base and then click on sketch path is the pentagon, and then the path is this stuff. So you see, the sketch is the one for pentagon. You can see the end is a pentagon, and then it follows the path I'd given earlier. So typically that's the sketch, that's the swept boss base. And then next, I want to illustrate the loft boss base. The loft boss base. Actually, the cuts are just opposite. For example, we saw that extended boss base, its opposite is cut. As this one increases the volume, this one removes the volume. That's the same way for the swept boss base. The swept boss base creates the volume, as you can see, and then the swept cut removes the volume. So let's try the swept cut and you see it. So swept cut, I can reuse the sketch by the way. Let me say I use a circular sketch. I want to create a circular sketch through it. I reuse the sketch and created first. No, I didn't want that sketch. Uh, this one. Now let's say it has a diameter of 0.5. So when you see here, like there's a circle of 0.5 going through the path itself. So swept cut is just an opposite of it, right? I see time is almost, it's really running, but I'm really working on it. So I'll do the most important feature next, which is one of the most important one is the lofted boss base. I'm just giving you the fundamentals. Remember that. So for the lofted boss base is, for example, different profiles. You use like different profiles to come up with something, right? So let's do an example. So for you to first work with swept boss base, I mean lofted boss base, you have to create various profiles, like 3 profiles or 4 profiles, or even 2 profiles, and then you connect them together using the command, the lofted boss base. So for this scenario, first you have to understand how to make planes, and the planes technically they are relative to the three. fundamental planes, or the three foundational planes you've been given. So, for example, take because I want to create it on the top plane going fast. So, for the top plane, you have to create another plane on top, on top, on top that way, right? So, I told you to create a plane. You go to reference plane like this, and then I want to base it on the top plane. So, the first reference will be the top plane, and then you can see you can specify the length of the distance between the two planes. For example, 20. Let me assume it's 30, 30 that way. So let me make the front plane, top plane visible so that you can get me. So you can see from the top plane, we have another plane which is 30 millimeters from the top plane. So let's say you want to create another one that's like 15 millimeters from plane one. So go to reference geometries and then go to the first reference. I'll give this one, but I want it to be like 15 millimeters from plane one. So that's it. I hope you can see how it looks like. So these are three different planes. So for the meantime, I'll hide these planes. And then I'll sketch on the top plane. So click on top plane and then sketch on it. Then I create a shape like this. This is a circle. Let's assume it's circle of diameter 50. Let's do 40. 40 looks nice. So you can see that's up. And then I sketch, I exit the sketch. So that's the top plane. Let me hide the top plane by the way. So let me show plane one. Plane one is on 30 millimeters on top of the top plane. So plane one is there. And then I click on plane one and then sketch on it. So let's say I'll sketch an ellipse over here. Let me just make it relative to the circle. Some of the sort, yeah. Then for the ellipse, I said you can give it the dimensions this way. I want to finish 3D modeling in the next 7 minutes. So let me assume it's 53. Then this one is, let me put it 70. Then let me fully define it. Let me align it with that one, horizontal. Then you can sketch it that way. You can exit the sketch. Then let me hide plane one. Then let me show plane two. Then let me sketch on plane two. Click on plane two, sketch. Then I draw another circle. Let's assume the circle is diameter, it's a smaller diameter, let's say of 25. So I exited the sketch. So you can see like I've drawn three different profiles in three different planes. Like each plane has its own profile. You can see the first plane was the top plane. I drew a circle on the top plane. Then I created another plane, plane two. On top of it, I drew an ellipse. Then lastly, I did another circle on the last plane. So typically, that's how to do it. So you can hide the rest by plane. You click plane and then hide it. Plane, hide it. Plane, hide it. So you can see we have three different profiles. So you can go to your lofted boss base. So you can do this by clicking the first, you can see, then the second, you can see it's following some sort of pattern this way, right? So I've selected the three sketches, different sketches to come up with something of the sort. Yeah. I hope you guys are familiar with containers like these used to put oil and such. So typically we use a lofted boss for the same. Yeah. So before I continue further, I want to do another last tool, another important tool, and then by 6:10, by the next 5 minutes, I should be done with 3D so that we go to assembly modeling. So there's another important tool known as the shell feature. So for the shell feature, let me do another example. Okay, let me do another example by the way. So I'll go to new. Okay. So let's say I want to draw a tumbler or a small glass. But then there's something I never taught you. That's how to give the circle dimension. I mean the angular dimensions. So for example, this is a tumbler, and then I give it this one like this. And then the angular dimensions, the angular, for example, you want it to be 100 millimeters. That's how you give it. Like just open the smart dimension and then click on this line, the line where you want it to be, like the two of them. It's going to give you the two. It's going to give you the angular dimensions. So let's say this is 70. Then this angular dimension is sorts. So let's. I want to teach you about the the shell. I didn't want to boss it. I want to revolve it. So I'll revolve it around that line. And then you can apply the tools you have used, for example, fillet. You can also do it in 2D this way. So for shell is used to make us a feature hollow, some with some thickness, right? For example, I want to make this thing hollow. Right now, you can't say this is a glass or a tumbler. You can see it's a block. Yeah, it's a block. You can see it's a block, and you can't store anything in it. Yeah, so when you want to check it, you can just click here on the section view, and you can see it's a block by itself. Yeah, but now you want to make it like hollow. So you give it a show, click here, show preview, and then give out the thickness of that, or the thickness you want. Let's say I want like 3 millimeters thickness. You can see the preview it gives. Ah, no, no, I have selected the wrong face. So for here, you select the face. I want to select the top face, and then you can see now the difference. It's a hollow. That's how you create a hollow using the shell command. When you click the section view, you can see how it looks like. So that's the shell picture. So you can also do it on your other models, like this previous model. Let me just close it. Don't save. So for example, this one you want to make it all. At the moment it is, you can see it's a solid. It's a solid. And you want to make it hollow, you use the shell command. So you click here and then give out let's say a thickness of 1.5. And then you click the face from where it will begin becoming hollow. So you see, let me just use the section view, so you can see how you have made something of the sort using a shell command. It's used to create hollows. Yeah. So from there, I think I'm done with the 3D modeling, and it was just so nice. I hope so. And just one last thing for the 3D modeling, I'll just love to illustrate what a draft is. So a draft is simply like giving a volume with the help of at an angle, or with the help of a taper or a taper. A taper is typically a draft, by the way. So let's say this rectangle this way, then you extrude boss it. When you extrude boss it, normally it goes straight, like typically straight. At the same time, there's this tool known as the draft tool over here. It's actually present in the boss base here, or you can get it at this point. So just click on it, then specify the angle of taper. So it's going to taper. For example, this one is tapering at 2 degrees, it's tapering at 3 degrees, it's tapering at 4 degrees. Then you can see it's a different thing. So that's what taper is used for. So from there, I hope you guys have truly loved it, and that's basics of 2D and 3D modeling. I've just covered the tools just to illustrate how you can use them and apply them in your various projects, just to give you an overview of it so that when you delve into SolidWorks, you find it easier to go along based on whatever we've learned so far. So by the means of reaction, if you've gotten it up to there, you can just like by reacting, or could just like so that I see that everything is handy. Okay, thanks so much. So that's just an overall view of the 3D, the essential tools. Because other tools are nice here, like wrap, you'll do them later on. But this time I was doing it from the perspective of a beginner. So I won't go on mixing values. But for it, everything that's just a wrap for the 3D and 2D sketches. So I just want to delve into assembly and I hope you guys have loved it. So I'll just delete this stuff over here. I don't want to increase my RAM. I don't want to crash my laptop. I know. So that's an example of revolve boss base. It's also revolve boss base. So we've typically covered most of the tools here, the bosses, the everything. Don't say. So for the next 9 minutes, I want to cover the basics of 3D assembly. So assembly, when you create like, for you to do an assembly like this, you have to create various parts. And since I don't have the parts, I'll quickly model some parts which I'll use to illustrate assembly modeling. So let me just design, let me just not design, let me just model the parts very, very fast. And I want you to take note of how to save the parts. So to make your work easier, you have to save your parts in folders. It's going to make your work very easy when you're working on projects or when you're doing like some some of your personal works that you don't mix your models. So let me just draw something very, very fast to make, which I'll use to illustrate uh, assembly. Assembly, I'll want to illustrate it in 10 minutes also because it's not complex. I'll just illustrate the top three mates, which I love, the concentric, the coincident, and so I love one known as the width mate, which is a bit advanced, but it's very, very crucial. Yeah, so for now, let me just do this very, very fast. Let me just do it very fast. Just follow along and see how I go about it. I'm not, I won't explain, but just follow along to see. So this is, let's assume it's 300. And then this one, I'll assume it's 150. Just follow along how I'm doing the 2D sketches. And then this circle, let me make it diameter 20 millimeters. Looks pretty well. So I'll do, then this one is 32. Let's assume it's 30. Then this one is also, that's not bad by the way. Yeah, so I'll just illustrate the tools you have used very fast. So this one I'll just mirror it into D. So mirroring into D, you just come to mirror command. Entities to mirror is that one. Mirror it about the center line. It comes naturally, right? Yeah, so nice. That's nice. Boss it. Let's say I want it 12 thickness. So this is an example of a part I've created, and then I'll save it. So whenever you want to save, you have to save in a folder. Don't just save anyhowly. Don't just save your projects in the downloads. Create a folder for your projects. And the way you have to do this is you have seen, let me just do it again. I'll go to save, save as. It's going to take me to my normal page, yeah? So the foundational locations where you can save your models. We have the desktop, you have the downloads, you have the documents. So let's say for my case, I do desktop. So I'll click on desktop. I want to save my things on desktop. And then I go to new folder. So I create a new folder and then I say like this is assembly practice, assembly practice one. So that's how I've saved my files, right? So you'll see desktop assembly practice one. That's the folder where I'll be saving my documents or rather my part documents. So I'll save this one as part one. Or let me just give it a name so that, so I'll save it as a plate part. Some of the sort. Then I'll click on save. So after I've saved, you'll see the part is saved here as plate part. My screen shows saved as plate part. So I'll close it and then I'll do another part, which is technically the bolts. I'm going to illustrate the types of mates in SolidWorks. So I'll go to the top lane and then quickly create just a weird bolt, not truly like a bolt, but I hope you'll get the concept. So I get like the hole was 20 dia, so I do 20 dia and then give it a height of 30 or 40. Let me give it 32. My memory is actually low. Okay, okay. Let me go back to my SolidWorks. So I'll give it a height of 32. So let me just do it very fast because of time. The next 13 minutes, I think, we'll be done with assembly basics. So this is 30. So I'm just drawing like a small bolt, right? It doesn't have to be perfect. If I had time, I would have done the perfect bolt, but right now, let me just do this. Allow me do this. So let's assume this is a bolt, like a bolt for your plates. So go here to save as, and then you'll see it will be saving automatically in the folder you created. So my parts will be together. So I'll save this as bolt, and then I'll close. So let me go to assembly. So assembly, before you begin assembly, you must make sure you have your parts and they must be dimension conscious, because if the dimensions are not rhyming, then you're not going to do it well. So when you go to home and then click assembly. So this is the assembly screen. This is how the assembly interface looks like. Yeah, this is how the assembly interface looks like. So the first thing you have to do whenever you open assembly, go to the assembly tab here. And the first thing you have to do is to insert the components you want to work with. So I'll click on insert components and then I'll, let me just go the normal way, browse. It will take me to the folder I created and then I'll create this bolt and part, plate part. Then I'll drag them into the assembly space, the bolt, and then my plates are there. Yeah. So let me check something. Okay, my evaluate tab is not there. Let me just use a command prompt. That's diameter 20. And then this hole is also diameter 20. That's why I said your dimensions need to be, your models need to be dimension conscious for you to work out these things steady well, right? So you can see these are two parts. You can see in the feature tree we have two parts. We have the bolt, and then we have the plate. Yeah. So you can see the plate is moving, and then the bolt is fixed. That's noted by the prefix fixed over here. It shouldn't be the case. Okay, for fixed, the first item you drag into the assembly space will be fixed automatically. But let's say we didn't want it to be fixed and we wanted this plate to be fixed because it's the most dominant model over here. So right click on the bolt and plate. But the rule of thumb is to always make one of the most dominant part to be fixed, right? So for example, I'll take this plate, right click on it and then fix it. So you see, it's not moving at all, but the bolt is moving. So let's say I want to fix this bolt into this hole. I use whatever is known as mates. Mates, they're just relations that I use to bring these things together. For example, you can see it's dragging itself here, but I want it to stay over here. I want it to go over here. So for mates, I said I'm only going to teach you three types of mates. You have the concentric, the coincident, and the width mate, which is, I find it a very important. But for now, let me go with the concentric first. So when you want to fix this here, you use whatever is known as a mate. So on the screen, you're going to see the mate. So click here on the mate. And then the selections. You see there are various types of mates. There are many mates. There are the coincident, the parallel, the perpendicular, the tangent, the concentric, the distance, and the angle mates. And then we have the, for for the advanced mates, we have the path, the linear, the and the limit mates, and then the analysis, and then we have the mechanical mates like the hinges, the gear, the rack pinion, and such. You don't have to know them right now. They're standard mates you have to know, like the concentric, the coincident, and the concentric. Those are the most important ones. Almost all the designs you'll have, you won't miss like concentric mate. I mean, you won't miss like the coincident mate. They don't miss most of the designs. So let me fix this one in here. So the best way to fix it, um, you go to your mate. So okay. Before I go to mate, just to give you an overview, the concentric, or rather the concentric mesh, is used for where the surfaces or the surfaces are cylindrical in nature, or circular, if someone will say cylindrical. For example, you see this face is cylindrical and this face is cylindrical, and you want to bring them together. You use the concentric mate. So go to mates and then select the face where you want. I'll select this face and I want this face. So you see itself, and SolidWorks will determine by itself that these are concentric mate because they are cylindrical faces being joined together. Yeah. So when you're done, you can click checked that way. So you see, when I try pulling it, it doesn't go in any other direction apart from where it has been constrained to. For example, this cylindrical shape will align with this other cylindrical shape. But now I want it to be fixed, assuming this is a plane. Yeah, that's where the concentric mate comes. I mean, the coincident mate comes in. It's used to mate like level surfaces, or used to mate like, or to bring two planar surfaces together, right? So, for example, this plane, let me exit mate. This plane is planar, and then this plane is planar. So typically, I want these bolts to come and rest over here, that way. Okay, I can't do it manually the way I've done it because you can see it's moving. It shouldn't be moving. I have to constrain it. Yeah, and the way to constrain it is use the consent coincident mate. I mean, so click on this face and then click on this top face. So the faces come together. You can see it's now it's not moving right now. So that's known as the concentric and the coincident mates. So for example, I want to bring this other part, this other bolt, and put it on this other side. That ways you can go to insert components and then browse and then select bolt and open. It's going to drag it again here. But that's a waste of time. Why should you go all that direction doing that? Yeah, just delete it, and you can simply drag, click on control and then drag whatever you want. I can drag this one, click on it and then control drag. You can see, just drag your mouse, or you can come from this feature manager like this and then drag it like this. So you're going to have various parts instead of inserting. But I don't need all these parts. I only wanted the bolt, so I'll just click on this and this, then I delete yes to all. I wanted only these two stuff. So I said I illustrated the concentric mate and the coincident mate. So I'll just redo it again for you to understand better. So go to mates and then align the cylindrical faces. For example, this cylindrical surface is supposed to fit on this cylindrical surface. So click on this surface and this surface. SolidWorks will do it automatically for you because it can tell. You can see, but I want it to be fixed. I want it to be fixed and not be moving like this, right? So I'll click on this face, like this face, and then this face. And then once you're satisfied, check it, and then you exit the mate. So you see, it has been created that way, and it truly makes sense, right? And then let's say I wanted to illustrate it further. I'll take this. I said if you want to create another part of it, just click on it and then click control and drag your mouse there. Yeah. So that's how you go about it. So it's this way. You can also explore other tools like rotate. Let's say I want to rotate it this way and make it that way. Then check it. But then you can also rotate there. Let me rotate a bit, but just like that there. But you can also move it if you want, like this. Bring it closer to where you want to mate it. So let's say I want to fix this plate to this other plate. So you just do the same thing. Go to mate, and then click on this cylindrical face and this. I didn't want that, but it's fine. I didn't want the edge. I want the face with this face. Ah, it's coincident. Okay, it was concentric. I want it to be concentric. So I'll go to mate. I'll click on this face and click on this other face. You see it's going by itself. You see it's swinging around that area. So I also do the same for this part, this face and this face. Click checked. And then you want this face to touch this face. Just click that, just simply click it, this face, touch this face. You see? Now that's how I've modeled two, like I've done an assembly of various parts. You can see the parts are here, one, two, three, four parts. Yeah, so these are various parts brought together and assembled together using the concentric. You can track your mates here. You can see I've only used concentric and coincident mates to come up with something of the sort. Yeah. So I see time is almost going, and okay, I'll only give like 10 minutes for Q&A. So let me just finish on this. I can do a practical example very fast, and that. So you see, so that's the mates, how you use it. And then there's another interesting mates. I think I'll illustrate it in the examples later on. But from there, I hope you guys have gotten a basic understanding of what mates are, the concentric and the coincident. If so, you can react by liking so that I know we are together in this. If you liked it up to there, you can just like it and tell me. Sure, thank you. So that's assembly, modeling. That's the basics of it. You have to know the mates. Yeah, I'll illustrate it later on by day. So I'll do an example and illustrate. So another thing I was to touch on was the exploded view. Exploded view is, for example, we want to do some sort of showing off in quotes. Okay, you're not showing off, but you just want to show off your work to someone how this assembly was made to make them understand. There's something known as the exploded view. I'll illustrate it, and then from there I'll do one practical example, and then we call it a wrap, right? So let me just illustrate the exploded view over here, and then I'll do one practical example, and then we call it a wrap. Sure. So go to exploded view is over here. It explodes the design, just as the name suggests. So for example, this one, I want to remove these two, we call it two bolts. So explore steps, click on the items you want to remove first. For example, this bolt and this bolt. The two of them are selected. You can see the color blue is there. And then I just drag it to a distance I want, like maybe up to there. You can see. And then after you're done, you click here, done. And then click this plate. And then you go to number two. You can see exploded view number two. Click on this. And then give it a distance you also want, like this. And then once the distance is satisfactory, click on done, and then click on this one as well. Just drag it down like that, then done. You can add as many styles as you want. For example, you want it to go back way, like click on this and then return it this way. And then done. So this also I want to bring it like this way. Then click on done. So after you're done with everything, you check there. So this is an exploded view of it, of the assembly. Yeah, but the assembly is still active. So when you want to view the exploded view, just go to the configuration manager over here. Is the third one. This one is the assembly manager, then this is the configuration manager. So you'll find the assembly here, and then this another configuration of it known as the exploded view. It's here. Yeah, just down click on it and then right click on it. You can collapse it. It goes back to its default, or you can animate it. I hope you can see it how it's going. It shows someone how something can be assembled or how something was assembled, the steps you like to follow. Yeah. For example, take that plate, bring it this way, bring it that way, bring it to the end, and then place the balls. So for there, I'll wrap it up for that. Let me do two practical applications of it. I already did the part, so it will be more of illustrations. But I hope you have understood there up to how to use the concentric, the assembly terms and such. So let me just do another assembly to illustrate this. So open assembly and then this, I'll browse. So my design, I saved it in downloads and then I saved it as a wheel. So this is the folder I'll be working on. So this is a typical one. So I'll do the assembly of this. Only two parts. So this one and this, and then open it. Then I'll drag them into the windows like this in the assembly mode or the assembly windows. So as I said, the first item that is dragged into the assembly space will be fixed. And for that case, it's this one, trolley. I did want it to be fixed. And then this one, you can see it's moving. Yeah, the wheel support. Yeah, so to reverse that, make it float so that it can move like this and then fix the dominant one, which is the wheel support. Fix it that way. Yeah, so you can see it's fixed and then you want to fit this one over here the middle of it. So as we did the mates, go to mates, you want to select the third type of mate. So the third type of mate the third type of mate comes in. The third type of mate is known as the width mate, as I had said. So go to mate, and then you want this surface to be mated with this cylindrical surface. You can see SolidWorks detect it automatically and it goes by itself over there. So it goes that way. So you can see it's mated there, but it's not in the middle. We wanted it to be at the middle. That's where the width mate comes in. Yeah. So you can see it's there. It's even rolling, by the way. For those who can see, it's rolling. You can't just see it. I think due to graphics. But that's how it is. We have mated it, but we want it at the center. Now that's where the width mate comes in. Width mate it's actually so it's advanced type of mate, but it's very crucial to you as a beginner. It will make your work easier. I never knew about it, by the way, until 1 year later. When I was using SolidWorks, is when I learned about the width mate, by the way. So I used to struggle so much, but now since you're starting and it's very well for you to know the width mate. So go to mate and then go to the advanced. Actually, this thing was like, let's say it was there, like, right? So go to the advanced type of mate, and then you're gonna get the width mate. So the width mate is generally used to position a model or a part to the center of another part or reference. So for example, I want this wheel to be at the center of this will support. So like I'll click like, for example, this. You can take any plane, for example, this face, for example, this face, a moment. I'll take this face and this face. And then I want it to be in the middle of either this face and this face, like the opposite. You can see it has just gone to the center by itself. So that's the width mate. So you can see it's perfectly at the center of the wheel support. Let me just illustrate it again for those who didn't truly get it. So you can delete mates by going here, delete, and then yes, and then I've gotten back to the normal. So I'll go back to the width mate, to the advanced types of mates. I'll go to the width mate as I said, and then you can click like this face, and this face. I want it at the middle of this stuff. So you can either choose the middle to be in relation to this and this, or the inner side and this inner side, or even this edge, this face at the bottom to this face at the bottom. It depends on how you want it. Let me just go with the inner one, like this one and this one. So I'll take it that way. So you can see it's perfectly aligned at the center. So that's the width mate, how you can do it, right? And you can also do exploded view of it, like just bring this wheel. It doesn't have any much parts, but just do like this and then done. Then go to features, you'll find here, then you animate collapse. You can see how it goes. Some of the sorts, yeah. So let me do one last example because time is not truly on my side or on our side. And last I'm doing the last assembly by day. So be very keen as well. Keep concentrating and get the best out of it. So I'll go to the one I did. This was a simple one. I'll do the belt roller. It's on the downloads, and then this is it. I did it some time back. So let me just drag the main parts very, very fast. The base, the bracket, the bush. Okay, I'll just do them very fast. Then the ring. I don't know if these are very important, but let me just drag them a bigger one so that at least you can see how it goes. So this is the base, which is the most dominant. Then this is the bracket. Then this is the bush. Then the roller itself, the hex flange bolts, the washers, and the shaft. So I'll quickly illustrate how to assemble this stuff. So these are various parts which you have modeled and brought together. So I'll just go very, very fast to make your work easier. So go to your main. So the part where I wanted to be fixed is already fixed. That's the base because I dragged it the first thing. So we're going to place this one over here. You can see over here. And then I place the bolts and everything, and then this one over there. So I'm going to illustrate other quick tools for you to master it very fast. So I'll go to mate, and then I'll see this one is circle. I mean cylinder. That's the horizon. That's the concentric mate. So I'll just like that face, that face. You see, it's going by itself, yeah, but it's not fully constrained. You can see it's still rotating, but you don't want it to rotate. So what do you do next? You can also constrain this other part, or you can also constrain the other circle, or you can use coincident mate to get this part to be fixed to that part. So let me use coincident for this part. So I'll click on this surface. I want it to be fixed to this face. So you see it's going by itself that way. You can see. And now it's perfectly aligned, you see. And then one thing, it's still not aligned as you wanted it. It's still moving. Yeah. So what do you do next? This face to come in contact with this face. Great. So you see, it's not moving at all. It's fully fixed to where you wanted it to be. And then the next thing you do, you can let me exit mate, and then let me rotate this bolt X flange. Let me rotate it, not move. Just do it this way. I'm finishing in 5 minutes. Yeah. So go to mate, and then like I want to find a cylindrical like that. I didn't want it to be so tangent. I didn't want it to be tangent. Let me find a way. That one, and then we go in mates, and then I'll do it this way. It goes. It's concentric, but you see, it's not fixed again, right? It's not fully fixed. So what do you do? let me, for the sake of time, I'll ignore the washers. So this one is here, then this one is here. That face and that face to be there. Yeah, so you can see, you can decide to do the same for the other holes, but SolidWorks makes our work easier by incorporating other useful tools that you can use. For example, for this case, we can use the mirror command. You can mirror actually in assembly. Yeah. So for mirroring command, you just click here on linear pattern and then go to mirroring command. And then I want to mirror these two to the other side and such. But first I have to mirror, I want to mirror this X flange to this other part of it. So let me do so. So let me find the center plane of this base. Let me see. Great, the front plane is suitable. I hope you can see what the front plane is. So I want to mirror this. So components to mirror, select there, then next, and then it's mirrored. You can see it's mirrored. So instead of wasting time reviewing and reviewing and reviewing, you can use mirror command to make your work easier. So go again to linear component pattern, down click at it. The last tool is the mirror command. And then you go to base because I want to mirror it in relation to the base. So I want to find a plane that's at the center at this point. So I'll go to plane and then I see the right plane, it's at the center of it. Click on it. And then components to mirror, select this one and then select the two bolts, right? And then after you've selected them, click here the arrow showing next. That way, you can see a preview of it. It makes your work easier. And then it's done that way. So you see I'm doing it very, very fast. And then the next thing we're going to do is to, for the sake of time, let me ignore the bush as well. Let me just remove it. Let's assume we had the shaft and the roller itself. So the next one we'll do is the shaft and the, so for the shaft, as I said, since this part is circle, it's cylindrical in nature, and then this part is also cylindrical in nature. Do it that way. And then I taught you a very important mate that is used to positioning it. For example, I want it to be at the center. So you can use planes, but for a beginner, I'll just say go with mate. It's very important. It makes your work easier. Yeah? So I want this stuff to be located at the center of this. You can use planes, you can use distance mates, but with mate is easier to use. So go to your mates, and then I'll go to advanced with, and then click at the end. So as I said, like for the width mate, you create two selections for the same shaft. For example, this part and this part. You've selected the shaft. You want it to be at the center of either this face and this face. You see, it goes by itself to the center. So the centers are extremely like they're relational in nature, right? So you do that and then you check it. So you see the shaft itself is just there, it's just rolling around it. Yeah. So the one which is remaining is to place this roller into the shaft. So I'll just take this face and that, no, I'll go to the standard mates because I'm using the concentric mate, which is a standard mate. So I'll go to this face and this face, and then it's going to automatically be concentric mate by the way. SolidWorks is going to do that for you. And then you can see it's now no, it's constrained along the cylindrical relation with the shaft. And for you to position it again at the center, you have to use the width mate, which is going to make your work easier. So go to advanced type of mate and then click on the width mate, right? So let's say the thing was here. So you want this part to be at the center of it, like the center, like where I've selected, that's the roller, to be in the extreme middle of this thing. Like you can also do this face and this face, or you can do this face of the shaft and that face, and then it's typically linked up. So typically this is it, and this is how we go about it. And you can see this is a simple assembly of a belt roller. And just to quickly do the exploded view, click on the exploded view. And since I want to remove these bolts as once, you can, okay, let me just do like this, click on this bolt, the bolts that way, and then specify some distance like this up to there. And then after you're done with that, just scroll a little bit and then click done. And then next, the next I'll remove. Okay, let me, for aesthetic purposes, I want to go with the DFM standards, but for aesthetic purposes, let me remove this one next. Okay, next there's this one. There's the actual. This one is for linear translation, like it removes it either based on the X direction or on the Y direction or on the Z direction. But this one now can move it in any direction. For example, I click on this and then I select these two. The actual one. This is the actual translation, by the way. Example, I want these two. I want them to move. You see, they are moving like two of them once. That's the actual ones. Yeah. Then after you're done up to there, just click done. And then I go back to my standard one so that I can remove the. So the actual one is used for two parts, like which you want to move like opposite directions but at the same time. So I'll go to the shaft. I'll go because it's I want it to move along the like X axis. I'll just click on it and then drag it this way up to there. And then after that I'm done. I click on done and then click on this one. Take it a little bit up to there. To that, click done, and then click on lastly this one. Pull it a little bit there, then click here, done. So this is you have exploded your assembly. So to view it, go to your configuration manager. Your configuration manager is here, configuration manager, and then you'll find the exploded view over here. Right click on it and then animate collapse, and then you can see how it's moving. I hope you can see how it moves. You can also increase the speed here. You can reduce the speed here by clicking that so that it goes slowly, or you go times two. You can see it's moving very, very fast. Yeah. So you can go slowly like that, or you go times two. So guys, thanks so much. Lastly, I'm just done, by the way. I'm finishing in the next 1 minute and then it's a wrap. I've done the assembly part of it and I hope you guys have truly enjoyed it. And then one last critical thing you have to know, like for beginner level, is to where to check your materials or where to put your material. Let me just do this very, very fast, like in 30 seconds or so. So, for example, material is very, I know you guys are doing engineering, some of you are hobbyists, and